Hello everyone, my name is Nand Kishore Yadav from ABES Engineering College, Ghaziabad. Today I am going to discuss circular queue data structure and various operations and its algorithm. So in a circular queue data structure, we can perform two basic operations. We can perform insertion operation where we can insert an element into a circular queue. We can perform deletion operation where we can delete an element from circular. Firstly, let's see what is a insertion in circular queue. So before inserting an element into circular queue, let's see how a circular queue look like. So suppose we are using array to represent a circular queue. Here, this is the array representation of a circular queue. For that, we have taken a circular queue 5 element. Okay, so this is the array we can use to implement a circular queue. So this is index 1, index 2, index 2, 3, and index 4. So circular queue means this array is also we can represent like this. Okay, this is 0th index element, this is first index, this is second, this is third. The benefit of circular queue is that when the array is circular, in that case, we can use the memory, reuse the memory for those elements we have already deleted in the queue. So suppose we want to insert some element like 20, 10, 30, 40, 11, 19 this. Firstly, in the case of circular queue, let's assume that the value of front and rear. If the queue circular queue is empty, in that case, the value of front is at -1, value of rear is at. So it's a similar case as we have done in linear. Now, just let's see how do we write an algorithm. So here we can write algorithm for insertion operation. For that, we have write insertion. Here we have taken a CQ array, implement it, and the data we want to insert. So in the first step, what do write? We write step 1, if front is equal to 0 and rear is equal to max or size minus. This first case we have to check in the case of circular queue. How it is happens here? Suppose we have inserted element 20, then value of front is this and rear is this. So both front and rear is set at 0, and we can insert 20 at this location. Now, for insertion of 10, what we do? We just increment the value of rear, and this one here we have stored 10 at this location, and this is next value of rear. And for insertion of 30, what we do? We can just increment rear from here, and Q of rear is again 30 here. Now, for inserting next element that is 40, what we do? We just increment the value of rear from 2 to 3, and we can insert a 40 at third index. Now, for inserting next element that is 11, again we can increment rear and the well at this location. So here we have inserted 11. Now, if you want to insert 90, then array is again full, and this is called the overflow case. Okay. So first case is that when front is at 0 and rear is at size minus 1, that is 4 here in that case, then the overflow occurs. What will be the second case in circular queue? In the second case, what we do, suppose we have deleted this element from the queue. So front will be at 10. Okay. At one index and front will be at 10. Now this location is vacant. Because the array is circular, then if you want to delete, insert 90 in the circular queue, then we can reuse this deleted space. Now, what do? We just set again the value of rear to 0. It means that this value we have to set up to here. Okay. Now the value of rear will be at 0. Rear is again set at 0, and we can insert CQ of rear is equal to. So here 90 is in place of after deleting 20, we can insert 90 at this. Now, suppose you want to insert another element 100, then now again the memory is full because the front is at next location and before that we have rear value. This is rear, this is front in this case. Now, this condition is again overflow condition. Then how do we write that case in algorithm? So we can see the value of front is 1 more than the value of rear, and then overflow occurs. So we can write the algorithm using this thing. For that, what we do, or second case is that when rear front is equal to rear plus 1, then again overflow. So both cases we have to consider in the case of circular queue, and then we can print overflow. So this is an important situation and exit from in the case of circular queue, where we have to see the overflow case using these two cases where front is equal to 0 and the rear is at size minus 1. Another is front is equal to rear plus 1, then overflow occurs. In second case, what do write? Then we have to check that if the array is full, array is full means the rear is at fourth location and before that index 0 is vacant. Index 0 is vacant. In that case, what we have to do? We have to set value of rear from size minus 1 to 0. So how do we write that case? So in that case, we have write if rear is equal to size minus 1, then before moving to this case, let's see if what happened if array is empty. But firstly, we have to discuss empty case. Second case will be if value of rear is equal to minus 1, then set front is equal to 0 and rear is equal to 0. Firstly, we have to see this step. Where front is 0, we have to set front is at 0 and rear is at 0 also. In third case, what do we do? Now we can use this one. If else, if a rear is equal to size minus 1, and then set rear is at 0. Okay, so when front is not 0 and rear is at size minus 1, then in that case we have to set rear at 0. In fourth case, simply works like ordinary array, ordinary queue or linear queue. So here else we just increment the value of rear is equal to rear plus 1. Okay. So here in the case of circular queue, we can see three cases. One is When the queue is empty, that is the value of rear is -1, then we have to set value front at 0 and rear is at 0. Else, if rear is equal to size -1, means a rear is at this location and previous location is vacant, starting location is vacant, then set rear is equal to size minus rear is equal to rear plus rear is equal to 0. Last case is that uh, normal case like a linear queue, we can simply increment value from rear to rear plus 1. If it is at 0, then we can increment to 1. If it is at 1, then we can increment it. The fifth step is that we can insert the data. TQ of rear, TQ of rear is equal to date. Now, after finding the appropriate value of rear, we can insert the data at that value, at that index. And next one is exit of. So in this way, we can write the algorithm for insertion in circular queue. Now, let's see how we can perform deletion operation in circular. So similar to linear queue, deletion in circular queue, there is no element, then again this case is called underflow case in the case of circular queue also. Firstly, we will write case. So for that, deletion in CQ. Okay. First step we can write if front is equal to -1, then print underflow and exit. Second case is that suppose we have an array 0, 1, 2, 3, and 4, and we want to insert element like we have element here like 20 is at here, 10 is at here, 30 is at here. Value of front is at this location, value of rear is at this. Okay. If want to delete some element like 20 from here, so what happened? 20 is later from this place, and we can increment value of front from this to this. Okay. So after inserting these three elements, we have deleted one element from the circular queue. Now again, suppose we can insert some element like we have inserted 40 at this location, the value of rear is at here, and we have inserted 50, the value of rear is at here. Now, if you want to insert 60 in this case, then what happens? The value of rear is set at 0. So we have inserted this rear value, this element 60 at this location. Okay. Now rear is at this point. Now we have to see these cases when we are going to perform deletion operation in a circular queue. First case we have discussed, if front is at -1, then print overflow case. Second case, we have to store the data firstly. So data is here, CQ of front value. Third case, we have to find the appropriate value of front and front variable. So what we see, we can see that if first case, if front is equal to rear, means this is the case when there is a single element. If we have deleted 10 at this one, okay, so for front is at this position. If you have deleted 30, then front is at this this index. If we have deleted 40, then front is at this index. Okay. Now, if we have deleted 40, then again front is at this index. Here we can see the value of front and rear is both same. If the value of front is and rear both are same, then in that case there is a single element in that circular. So we have to include this condition also. For that, we can write here else if. Okay. For that, we have can if front is equal to rear, then set front equal to -1 and rear is also is equal. Means make it empty. Another case is when the value of rear front and rear value of front is at size -1 and already we have inserted element at starting index. Then again a rear can move from this position to. So we have to include this case also. For that we can write here if a rear is equal to front is equal to size -1, then what do we write? Then front set at 0. Okay. In this way, front is moved from last position to first position. Now, last condition is that else rear is equal to, we can write here front is equal to front plus 1. Is similar to linear cube. Okay. In sixth step, just we can perform exit operation. So this is the algorithm for a deletion operation in circular.